Hi guys, welcome back to the channel. My name is Jai, and in today's class what we're going to do is start with Chemistry 12. The topic we're going to go through today is electron configuration with orbital diagrams and how to draw it out. So with that, let's get started. Alright, so here we are. Okay, so I put down electron configuration and orbital diagrams. Okay, so what we're going to do first, the electron configuration, okay, is basically just telling you, okay, in terms of how many electrons are found within each element. Okay, so what we're going to do is I'm going to write down the electron, okay, configuration chart. Okay, just so we can look at it as well. Okay, so I have different orbitals. Okay, I have orbital S, orbital P, there's orbital D, and orbital F. Okay, so what you're going to do is when you're actually writing it down, you start off with orbital S. Okay, you number it down up to 7. So 5s, 6s, 7s. Everyone see that? Okay, so this is, we'll go through the electron configuration chart first, but then also by just looking at the periodic table, you should also be able to write out the electron configuration. So then we're going to start with P. Okay, so just line it up here, and again, just go up to 7p. So, so 4p, 5p, 6p, 7p. Okay, the next orbital is D. So we're going to start with 3. So you can see that there is a pattern here. And 7, so let's just keep it at 6D. Okay, and the reason it's like this is because for some of them, okay, there won't be an orbital for that. So just like if you look at orbital F, okay? And so in the first orbital, so orbital S can actually hold, let's write down how many electrons. Orbital S can hold up to 2 electrons, okay? Like that. Orbital P can hold up to 6 electrons, okay? And then orbital D can hold 10 electrons, okay? Orbital D actually represents the transition metals here, okay? And then orbital F can hold up to 14 electrons. Okay, and that's only if we're looking at the element and it has a really high atomic number here, okay? So let's try an example. Let me draw the arrows so we can see it. So the arrows are going in this direction here, okay? I'm just making straight arrows. Make sure you're watching the numbers that you're drawing the arrows through, okay? So the 3p and 4s should be in order like this, okay? And then the 3D, the 4p, and the 4s. Oh, and the 5s should be in order. So I'm going to make the arrows a little bit longer so we can see it here. Okay, and then it's 4D, 5p, and 6s. Okay. And then lastly, I have the 4f, 5d, 6p, 7s. Okay, and you're just following this pattern. Lastly, the 5f, 6d, okay, and the 7p. This is a general order, okay, that we're going to follow. So let's try something simple here, okay? So say I have lithium. Okay, so we all know lithium is Li, okay? And what we're going to do is write the electron configuration for lithium, okay? So I do have to look at how many electrons. So lithium is in group 3 here, okay? Okay, as in it's in group 1, okay? But it has 3 electrons altogether. So I think we'll just write 3 electrons. Because the electrons is what we need to represent, okay? So we start off from the top of the table here. It's going to be 1s, 1s2, like we said. The s orbital holds 2 electrons, okay? And after that, we're going to go to the 2s, okay? 2s can also hold 2 electrons, but I only need 3 electrons altogether. So the exponent is just going to be 1. Does everyone see that? So this is the electron configuration for lithium. Okay, let's try a different one. Okay, let's try carbon. Okay, so carbon is C. Okay, and if you want to look in the periodic table again, the atomic number is 6. Okay, so remember the atomic number gives you the number of protons. Okay, in an electrically neutral atom, okay, it's also equal to the number of electrons. So one more time, let's use the chart here. Okay, so we're going to start with 1s2. Okay, then we're going to go to 2s, so 2s2. So I have 4 electrons so far. After the 2s, I'm going to go to the 2p. Okay, so let's write 2p. Okay, and again, I need to have 6 electrons altogether. Okay, so here I have 4, so I'm going to put 2 here. Okay, when you add all these exponents together, okay, it's equal to 6 electrons. Everyone see that? Okay, with that, let's try one last example here. Okay, let's try something a little bit bigger. Let's try fluorine. So fluorine is F. We're going to write the number of electrons, okay? And the atomic number is 9. So we'll just put 9 electrons. Okay, does everyone see that? So one more time, we're going to start with 1s orbital. So 1s2, 2s2. Okay, so I have 4 electrons so far here. And again, I'm going to go to the 2p orbital. Okay, and I only need 9 electrons altogether. The p orbital, again, if you look up here, can hold up to 6 electrons. So this is 5 plus 2 plus 2, which altogether gives you 9 electrons, okay? And you see, as you keep on increasing in the periodic table in terms of the elements, I'm just going to keep increasing my orbitals using my electron configuration chart up here. Okay, everyone sees how to do that? All right, good. And so if there are no questions here, let's try the orbital diagram for lithium. Okay, so when you draw the orbital diagram, it's going to be like this. You just use these square boxes, okay, to indicate the electrons. Okay, so you see how there are 2 electrons here? The spin on the electron are opposite. Okay, so we're using arrows to show the electrons. The spin is going positive 1/2 in one direction, and then negative 1/2 in the other direction. Okay, you can use half arrows like this as well. So we'll put 1s. Then we're going to go to the 2s, okay, orbital. Okay, and I noticed that there's only 1 electron in the 2s orbital. It's going to be going up, okay? With that, let's look at carbon. Okay, so one more time, I'm going to make a box. This is my 1s orbital. And I see I have 2 electrons there already, okay? I'm going to make my 2s orbital like this. Okay, it is easier if you write out the electron configuration first. So I see 2s also has 2 electrons. One is going up, the other one's going down. Okay? When you get to, okay, this is now the 2p orbital, okay? And the 2p orbital, we're going to actually draw it like this, where you have 3 boxes. The reason I have 3 boxes is each of these boxes can hold 2 electrons. Okay, and like we said, the p orbital can hold up to 6 electrons. Okay, and in this case, I only have 2 electrons here. Okay, according to Hund's rule, what it says is when I draw these 2 electrons, I'm not just going to draw it in one box here. I'm actually going to draw it in separate boxes. Okay, each of these suborbitals have to be filled before you start to pair them up. Okay, and that's what Hund's rule is here. Okay, say I draw the orbital diagram and you drew both of these electrons in just one box. That's actually wrong. Okay, and the teacher will take off a mark for that. All right, and lastly, let's take a look at fluorine here. Okay, so one more time, this is a good example. I'm going to draw the 1s orbital. I see I have 2 electrons. For one of the electrons, the spin is going to be positive. For the other electron, the spin is negative. Okay? And then we're going to go to the 2s orbital. Again, I notice I have 2 electrons within the s orbital here. One is going up and the other is going down. Oh, so maybe put 2p here. Okay, you should actually be writing the name, okay, of the orbital that the electrons are occupying, okay? And then lastly, let's draw the 2p orbital as well. So this is a good example, like I said. Okay, this is 2p5, okay? So what we're going to do is in each of the suborbitals, okay, you want to draw 1 electron first, 2, 3, like this, okay? And now because each of these suborbitals is filled, I can actually start pairing them up, okay? And so when you pair it up, it's just going to be 4 and 5, all right? And this is basically what fluorine looks like, okay, in terms of its orbital. Okay, so on this side, these are the orbital diagrams. Okay. So I can see that it's actually very simple, okay, in terms of drawing out the orbital diagrams like we did here, as well as writing the electron configuration. Okay, you can just use the electron configuration charts. In the next video, what we're going to do is see how we can use the periodic table to actually just write out the electron configurations. And that way you don't actually have to memorize this electron configuration chart. All right? Okay, so that looks good. And if there are no questions, that does bring this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel. And I will see everyone in the next video. Thanks. Bye.